This is the most dangerous man-made object in history. The Tsar Bomba, codenamed in 602, nicknamed the King of Bombs. It was not just a weapon, but a statement of absolute Soviet power during the Cold War. To understand its power, first look at its size. The Tsar Bomba measures a staggering 8 meters in length. The bomb's body diameter reaches 2.1 meters. It is as wide as a small subway tunnel. Let us compare it to a human. An engineer standing next to it looks like a tiny toy. Compared to Little Boy the bomb dropped on Hiroshima, the Tsar Bomba is a true giant. In fact, its dimensions are equivalent to the length of a London double-decker bus. It weighs 27 tons. That is equivalent to 5 African elephants combined. The Tsar Bomba's outer casing is crafted from high-strength aluminum and steel alloys, designed with a sleek aerodynamic shape. However, this size was a nightmare for the Tu-95 aircraft design team. The bomb was so massive that it not fit inside the strategic bomber standard bomb bay. Soviet engineers were forced to cut away the bomb bay doors and auxiliary fuel tanks within the fuselage. As a result, when loaded, more than 50% of the bomb's body remained exposed outside the aircraft's belly. The nose of the Tsar Bomba was designed with a rounded shape to reduce air resistance during free fall. At the rear are large box-like stabilizers, which prevent the bomb from tumbling uncontrollably. But this massive metal shell is just camouflage for the true monster sleeping inside. Let us strip away the aluminum armor to see the engine of destruction. Inside the N602 lies a complex multi-stage design known as the Teller-Ulam configuration. First is the primary. This is essentially a small atomic bomb located at the nose of the weapon. Its sole purpose is to act as a matchstick. When detonated, it triggers the main event. The explosion sends a flood of high-energy X-rays traveling down the bomb's casing at the speed of light. These X-rays strike the secondary, a massive cylinder containing the thermonuclear fuel. Inside this cylinder are layers of lithium deuteride, the dry fuel for fusion. At the very core of this fuel sits a spark plug, a rod of fissionable plutonium. The intense pressure from the X-rays compresses the secondary stage, igniting a fusion reaction hotter than the sun. Originally, Soviet engineers designed a third stage to boost the yield to 100 megatons. To achieve this, the fuel tamper would need to be made of uranium-238, which would fissure violently. However, the fallout from a 100 megaton blast would have poisoned vast areas of the Earth. At the last minute, the design was modified. The uranium tamper was replaced with inert lead. This substitution absorbed the fast neutrons, cutting the yield in half to 50 megatons. Ironically, this made the Tsar Bomba the cleanest nuclear weapon ever tested, deriving 97% of its energy from fusion. But even with the power reduced, delivering this device safely was still a suicidal physics problem. Dropping a 27-ton bomb creates a deadly physics problem: gravity. Without a braking system, the Tsar Bomba would fall too fast, and the Shockwave would destroy the delivery plane. The solution was an elaborate multi-stage parachute system housed in the tail. It was not just one parachute. The Tsar Bomba used a sequence of 5 different chutes. The main parachute alone covered an area of 1,600 square meters. This massive canopy was so heavy that the parachute canister itself weighed 800 kilograms. When fully deployed, the parachute slowed the Tsar Bomba's speed from a jet's velocity to a manageable descent. This brought the Tu-95 crew exactly 188 seconds to fly 45 kilometers away from ground zero. While hanging in the air, the Tsar Bomba's internal brain wakes up. Specialized thermal batteries are activated to power the firing circuits. A complex series of safety switches must arm in a specific order to prevent accidental detonation. But how does the bomb know exactly when to detonate? The Tsar Bomba is equipped with 3 independent radar altimeters. These sensors constantly ping the ground to measure the drop in altitude. The target detonation height is set strictly at 4,000 meters above sea level. At this specific altitude, The fireball maximizes destruction without touching the ground, reducing radioactive fallout. October 30th, 1961. The Tu-95V bomber reaches the drop zone over the Novaya Zemlya archipelago at 11:32. The release mechanism engages. The Tsar Bomba disconnects and begins its lonely fall. Immediately, the pilot engages the afterburners. The crew has only minutes to outrun the apocalypse. At an altitude of 4,000 meters, the sensors trigger. The Tsar Bomba detonates. Within a nanosecond, a fireball formed, expanding outwards to a diameter of 8 kilometers. The flash is so intense it can cause third-degree burns 100 kilometers away. Then comes the shockwave. It strikes the escaping Tu-95 bomber, causing the plane to drop 1,000 meters instantly. On the ground, the blast wave flattens everything. The village of 55 kilometers away, ceases to exist. The shockwave circles the entire globe 3 times. Windows shatter as far away as Norway and Finland. Rising from the devastation is the mushroom cloud. It punches through the clouds and keeps rising. The cloud reaches a height of 67 kilometers. That is 7 times higher than Mount Everest. The top of the cloud stretches into the mesosphere, reaching a width of 95 kilometers. The total energy released is 50 megatons. This is 1,570 times more powerful than the combined bombs of Hiroshima and Nagasaki. It contains more explosive energy than all the explosives used during the entire Second World War multiplied by 10. Despite its power, the Tsar Bomba was never deployed militarily. It was simply too heavy and too impractical for real combat. The N-602 remains a terrifying monument to Cold War physics the day humanity built a sun, and fortunately, decided never to use it again.